In preview activity 3.2, we're given a function of this form, f of x equals a times the quantity x minus h squared plus k. Now this is familiar to us in that it's a form of a quadratic function that is horizontally shifted by h units to the right or left, depending on if it's positive or negative. It's vertically stretched or compressed by a factor of a. If a is negative, that will reflect it over the x-axis. And then it's vertically shifted up or down by k units. So this is a transformed quadratic when we look at it as transformations of the function x squared. Now in B, we're going to use calculus to figure out what's going on with the critical points. So we're going to first find our f prime of x for this function. So taking the derivative of this, we have a chain rule. A is just a constant. Chain rule says pull the 2 out front, so 2a, leave the inside alone, x minus h, decrease the exponent by 1, so that becomes a 1, times the derivative of the inside, which is just 1, plus the derivative of k. K is a constant, it doesn't depend on x, so its derivative is just 0. So our derivative is 2a times x minus h. Right, so we only have one critical point in this function, and it's at h, because that's the only thing that's going to make the derivative 0. So let's make a sign chart for part C. And what we'll do is we'll label our value of h. Now we're assuming that the a value is less than 0, so we can use that when we test our values. So remember what we do, we test in the derivative, and that gives us what's going on in f. So if I use a value smaller than h, and now we don't know if h is positive, negative, or 0, but if I use a value over here, then what's going to happen is when I do x minus h, and I'm using something larger than h, we're going to get a negative value from here. But remember, a is less than 0, so a negative times a negative is positive over here, which means we'd expect f to be increasing. Now if we pick something to the right of h, that means we're picking something larger than h, so the difference between that and h is going to be positive. A is negative, so a negative times a positive is negative, and our function is going to be decreasing. So if we look, our critical value at h, we have a relative maximum, or local maximum, because our function goes from increasing to decreasing. Now because this is a quadratic, this is also going to be an absolute maximum at h.